Hi, this is English Shabana Sultana, working as Associate Professor in the Chebrol Engineering College, Chebrol. In the last lecture, I discussed about the two types of fuel cells. Those are hydrogen and oxygen fuel cell and methanol and oxygen fuel cell. Today's class, I want to discuss about the phosphoric acid fuel cell, which is known as PAFC. This phosphoric acid fuel cell, it is used as a liquid phosphoric acid, and this phosphoric acid is used as an electrolyte in the saturated and silicon carbide matrix, that is SiC matrix. Coming to the construction of the fuel cell, this is the diagram of the phosphoric acid fuel cell. In this, two types of electrodes are present. One electrode acts as an anode and other electrode acts as a cathode. The anode which we are taking, it is made up of carbon coated with finely dispersed platinum catalyst. Whereas the electrolyte which we are taking here in between the anode and cathode, which are sandwiched, it is a phosphoric acid. And this phosphoric acid, it generates the electricity in the fuel cell. It is more than 40% efficiency. One of the main advantage of this type of fuel cell is that it can be used impure hydrogen as a fuel. Here at the anode, one inlet is there to enter the hydrogen gas as a fuel. And here, near the cathode, the inlet is there to enter the gas, that is the air. In air, oxygen, so many gases are there. But exclusively near the anode, the hydrogen gas was taken. So this is about the construction of the fuel cell. Coming to the working of the fuel cell. In this, the reactions that are taking place at the anode and the cathode is, at the anode, I already told you that the hydrogen gas is taken as a fuel. This hydrogen, it dissociates into H plus ions and electrons is liberated. This electron will move towards the circuit, that is electric current, and it is moved from anode to cathode in this direction. And it enters near the cathode, and at the cathode, the oxygen gas, it is passed through the inlet, and this oxygen, it is react with the H plus ions, and it also taken the electrons also, and water will be generated. This water, it comes out through this outlet which is present at the top of the fuel cell, and whatever the fuel, that is hydrogen gas, it is taken towards the anode. After the reaction, the excess of the fuel cell comes out through the outlet in this way. This is the overall reaction. And in this, the water is generated, which comes out through the outlet. And this water, it is used by the submarine and military vehicles. And coming to the applications of the phosphoric acid fuel cell, it is used for stationary power generator with output of about 100 kilowatts to 400 kilowatts, and it is used for the large vehicles such as the buses. And in India, DRDO has developed the phosphoric acid fuel cell for air-independent propulsions for integrations into submarines. So that is about the phosphoric acid fuel cell. Coming to the molten carbonate fuel cell. The utilization of electricity in natural gas, biogas, and coal-based power plant is by molten carbonate fuel cell. And this molten carbonate fuel cell, it is used as a carbonate salts of alkali metal as electrolyte. And this is a construction of the molten carbonate fuel cell. This apparatus consists of the anode and the cathode. The electrolyte is a molten mixture of alkali metal, which is made up of either the lithium, sodium, potassium carbonates at a temperature of about 600 to 700 degrees centigrade. This is taken in an inert porous matrix sandwiched between the two porous nickel electrode. That means the anode and the cathode is made up of nickel. Gaseous mixture of oxygen and carbon dioxide, which is relatively inexpensive to manufacture, can be used in the cell. That means towards the cathode, the oxygen gas from the top of the apparatus and the carbon dioxide from the bottom. Two inlets are there near the cathode. One inlet is used for the passage of the oxygen, and one inlet is used for the passage of the carbon dioxide gas was taken. And the hydrogen gas is taken or is supplied to the negative electrode and oxygen to the positive electrode. The discharge of the EMF of the cell is about 0.8 volts. And this anode, it is made up of the nickel based alloy with 2% either the chromium or aluminum. The materials are creep resistant and prevent sintering of anode at high temperature. The cathode consists of the porous nickel, which is converted into lithiated nickel oxide. The electrolyte consists of sodium potassium carbonate supported by the ceramic matrix to maintain the liquid between the cathode and anode. Coming to the working of the molten carbonate fuel cell, the reaction that are taking place at the cathode and the anode and cathodes are, at the anode, as usual, the oxidation reaction takes place with the liberation of electrons. And I already told you that the hydrogen gas is passed towards the anode, which combines with the carbonate ion to form water, carbon dioxide with the liberation of electrons. This water and carbon dioxide will be passed down, and the electrons are moved in the upward direction towards the electrical current, and it is passed from the anode to cathode. Whereas the liberated water and the carbon dioxide, it moves in the downward direction, in this direction, and the water is comes out as a primary source of drinking purpose, and whatever the carbon dioxide which is generated in this process, it moves down and it is again circulated, and it is moves towards the cathode, and it is supplies near the cathode. Whereas the reaction which was taking place at the cathode is whatever that the electron which are coming from the anode, it made to react with the oxygen gas. Here there is an oxygen inlet, gas inlet is there. Though that an upcoming oxygen is made to react with the carbon dioxide, the electrons, and form carbonate ion. And this carbonate ion is moved into the solution, that is in the electrolyte. The overall reaction is H2 plus half O2 that gives rise to water molecule. Coming to the applications of the molten carbonate fuel cell, this cell is used in many industrial purposes to produce electrical current via steam turbines. And the advantages of or the uses of this molten fuel cell, it is used for portable, backup, transportation, and stationary power applications. Portable power. Portable powers are, these are the fuel cell which are light in weight, long lasting, portable power sources that prolong the amount of time a device can be used without recharging. And coming to the backup power, this backup power is a type of fuel cell. It is used for the backup power comes in many sizes and types and typically use hydrogen as a fuel cell. Transport applications, fuel cells can be used for many transportation applications, including automobiles, buses, utility vehicles, and scooters and bicycles. The operating temperature of an automotive fuel cell is between 60 to 80 degrees centigrade. Stationary power applications. Stationary fuel cells can be used as a primary source in hybrid power system. This fuel cell can be connected to photovoltaic, batteries, capacitors, wind turbines, providing primary or secondary power. So this is about the molten carbonate fuel cell. The next topic is a corrosion. Before going into the lesson corrosion, we should be familiar about the electrochemical series and galvanic series, so that we should have some sort of knowledge about which metal undergo corrosion, what is a corrosion, why the metal undergo corrosion, what is the consequences of corrosion, which metal undergo corrosion fast, which metal does not undergo corrosion. So these are all related to the Electrochemical series. Electrochemical series means when the metals are arranged in the order of increasing reduction potential or decreasing oxidation potential, which are determined with respect to 1 molar solution of their ions and measured on hydrogen scale. A long series or list was resulted, which is known as electrochemical series. Wait a minute, I'll show you. So this is electrochemical series. So in this, the higher a metal is in the series, the greater is a tendency to be oxidized. The metals high up in the series are strong reducing agent and the ions are stable, whereas those near the bottom of the series are inactive, stable metals, and the ions are easily reduced to metals. Any metal can produce any cation below it in the series from its 1 molar solution. Any metal above the hydrogen will displace the hydrogen from dilute acid solution. For example, sodium. Here is a sodium which dissociates into Na plus, and the position of the sodium is above the hydrogen. So it can displace the hydrogen easily from dilute acid solution. So the sodium, it reacts with water to liberate the hydrogen because the electrode potential of the sodium is minus 2.714 volts, which is less than the electrode potential of hydrogen. Because the electrode potential of hydrogen is 0. The value is more when compared to that of the electrode potential of the sodium. The oxidized form of any metal below the hydrogen in the series, that means these metals which are present below the hydrogen in the series, will be reduced by hydrogen. That means the metal above the hydrogen in the series can displace easily, whereas the metal which is present below the hydrogen in the series from a salt solution is the value of the zinc. Suppose if you take the zinc, the electrode potential value is minus 0.76 volts, which is less than the copper, whose electrode potential is plus 0.34 volts. The metal above the hydrogen in the series can be easily oxidized, hence they undergo corrosion easily. Whereas the metal which is present below the hydrogen can be reduced, and hence these metals are protected against the corrosion because it undergo the reduction and they are resistant to corrosion. This electrochemical series, it gives the information on relative corrosion tendency of the metal and alloys. That means which metal will corrode easily, which metal is being protected. So it gives a relative corrosion tendency of the metals as well as the alloys. And it gives the information about the relative ease of oxidation or reduction of the metal. And it also gives the information about the replacement tendency of the metal. And it is also used to calculate the equilibrium constant by using the formula E naught is equal to RT here. RT by K NF, which will be given as E naught is equal to 0.0591 by N into log to the base 10 at 25 degrees centigrade. So this is about the electrochemical series. So now we'll go about into the unit, that is of corrosion. I'll give the brief introduction about that before going into the lesson. What is corrosion? Corrosion means it is a deterioration or the decay of the metal by the reaction with the environment is called corrosion. And the metals and alloys are important engineering material with a wide range of applications. The surface of almost all the metals begin to decay more or less rapidly when exposed to environmental conditions like gaseous atmosphere, water, or another reactive liquid medium. As a result of the decay, the metals are converted to their oxides, hydroxides, carbonates, sulfides. That's why the process of the decay of metal by environmental attack is called corrosion. For example, formation of reddish brown color layer of the rust on the surface of the iron because of the formation of this Fe2O3 3H2O, it forms the color that is a reddish brown color layer, which is called the rusting of iron. And the formation of green film of carbonate on the surface of the copper is known as the rusting of copper. The appearance of the green color is due to the formation of the carbonate layer and the formation of the black colored layer on the silver. The corrosion of the metal is measured in units of milli-inches per year or millimeters, per year. So these are the units of the corrosion. Coming to the cause of corrosion, why the corrosion will take place. The basic reason for this attack is most of the metal, except platinum and gold, exist in nature in the form of their minerals or ores, which is a stable combined form as oxides, chlorides, silicates, carbonates, sulfides, etc. During extraction of the metal, these ores are reduced to metallic stage by supplying considerable amount of energy. Hence, the isolated pure metal, here, this is isolated pure metal, which are regarded as an excited state than the corresponding ore. These excited states of the pure metallic form will have the higher energy and less stability. As a result, when the metal is exposed to the environmental condition, such metal, if it is exposed to the environmental condition, like dry gases, moisture, and liquids, the metal surface react and form the more stable compound of metals, which are thermodynamically stable state, like oxides, carbonates, etc., more rapidly. For example, iron undergo corrosion to produce brown colored hydrated ferric oxide, which is nothing but rust on the surface. As a result of corrosion, the loss of metal takes place, and the process of corrosion is reverse of metal extraction as shown in the figure. In the pure form, this one, the metal possesses the engineering properties like malleability, ductility, and electrical conductivity. When corroded to compounds of metal which do not possess engineering properties, metal cannot be used as an engineering material. Metal cannot be used as an engineering material. Finally, I want to conclude that the metallic compound which is in the ore form, it exists in nature in this form, which is a more stable and having the less energy. In this stage, the metal have the less energy. The pure metal is extracted from the ore by the process of metallurgy at high temperature. This pure form have high energy and less stability. So the pure metal is ready to react with the environment to attain the stable impure form. So that is about the cause of corrosion. Coming to the consequences of corrosion. That means what are the disadvantages of the corrosion process? In the entire universe, more than 30% of the metal undergo corrosion without using after manufacturing. The valuable metallic property like conductivity, malleability, ductility are lost due to corrosion. The process of corrosion is very harmful and is responsible for enormous wastage of the metal in the form of its compounds. It is estimated that the amount of iron wasted by corrosion each year is about 1/4 of its annual world production. Lifespan of metallic parts of the machineries is reduced. See, due to corrosion, machine part undergo sudden failure and it may lead to the loss of life. The failure of machineries takes place due to loss of useful properties of metals. Losses occurring due to corrosion cannot be measured in terms of cost of metal alone, but the high cost of fabrication into equipment, machine tools, and structures should also be considered. The approximate estimate of loss of metal due to corrosion is $2 to $2.5 billion per annum all over the world. Hence, an engineer must understand the mechanism of corrosion so that the effects can be minimized by avoiding the corrosion conditions and provide simultaneous protection against the corrosion. And due to the corrosion of highly inflammable chemical storage tanks, it may lead to the danger of explosion. Due to surface corrosion, metal loses its smoothness. So this is about the consequences of corrosion. In the next lecture, I would like to tell you about the theories of corrosion and the types of corrosion. Thank you.